Okay, in this video I'm going to continue on with exercise 5b of the book Fundamental Applied Mathematics. We're on page 131 and the question is 10. So initially we're asked to define momentum. So we know of course that the formula for momentum is mass times velocity and both are vectors. So we can say that the momentum is the product of the mass with the velocity vector and its unit is kilograms meter per second. Next we're asked to define 1 Newton. So we know from Newton's second law that the sum of the forces is equal to the mass times the acceleration. So when this is equal to 1, we have a Newton. So 1 Newton is where the product of the body's mass and its acceleration is of magnitude 1. Alright, so that's pretty straightforward. Now the second part of this question is actually quite interesting. It's something you can definitely relate to, so let's just get stuck in. It reads that a lift is carrying people up. I'll start from the start. A lift of mass 1440 kilos carrying 8 people, each of mass 70 kilos, is being hoisted vertically upwards by a rope with tension 24 kilonewtons. Calculate the acceleration. So if you just do a small bit of playing around, you'll find, multiply the mass of each person and add it to the mass of the lift, and you're going to find that there's 2000 kilos in your lift. You're told that there is an acceleration of 24 kilonewtons, so 24,000 newtons, and you're accelerating in an upwards direction. So of course the weight is going to be negative 2000 j hat. So if we apply Newton's second law, which says that the sum of the forces is equal to the mass times the acceleration, you're going to find that 24,000 minus 2000 j hat is equal to 2000 j hat. So A turns out to be equal to 2.2 j hat. So the whole thing is being accelerated upwards at an acceleration of 2.2 meters per second squared. So that's fine. The next part though, however, says determine the reaction between the floor of the lift and each person. So let's just redraw this. We know that everybody in the lift is now being accelerated by a magnitude of 2.2 meters per second squared. So let this be the floor of the lift and this box represent all the people. So it's equal to 560 kilos in weight. In mass, and its weight is equal to negative 560 j hat. Now, ask yourself, how does Newton's second law apply? If the sum of the forces was equal to 0, then A would be equal to 0, however we have an A. So that means that the sum of the forces cannot be equal to 0. And you might say, well, how does that make any sense? And the reason it makes sense is because you're in an accelerating frame of reference. You're no longer just standing on the ground. You're moving, so as a result the forces aren't going to be equal. You're not going to have an equal but opposite reaction. So what that means is that that means of course that the normal force cannot be equal in magnitude to 560 g. It must be greater than it in order to accelerate upwards. If you're accelerating downwards, then your weight vector would be greater than your normal vector. So let's just see what happens here. So the sum of the forces is equal to n minus 560 g in a j hat direction. That's equal to 560 times 2.2. So n is equal to 560 times 2.2 plus 560 g. Divide that by each person and you're going to get the fact that we have 840 newtons of a reaction force per person. Alright, you might say to yourself, well, how is that interesting? So let's look at the weight of each person if they're on the ground. We know the weight of each person, or we know that the weight of all 8 people on the ground is 560 multiplied by 9.81. So what's the weight per person? So there are 8 people, so the weight per person is 696 per 696. So this is air, and on ground is equal to 686. Now, what you should realize is that when you're on the ground, you are acting on the earth with your weight. However, the earth is acting against you with the normal force, which we know. And what you feel as your weight is actually the normal force. You don't actually feel your weight. What you feel is what the earth pushes up against you with. So what I'm saying to you here is, your perceived weight on the ground is 686 newtons. That's what you standing on the ground would feel. And in air, we're told, in accelerating inner lift upwards, you're told that you suddenly weigh heavier. Now you haven't got fatter, you haven't put on any more mass, so this must be a new phenomenon, and it's due to the fact that there are different forces acting upon you. And think about it, if you're in a lift and it's accelerating upwards, you feel heavier. You feel that there's more pressure on your feet than there usually would be. And that makes sense. Now obviously, if you're accelerating downwards, if you were in free fall, for example, your weight vector would be greater than the normal vector, and that's why you would feel weightless. Alright, so that's all I've got to say about that. Thanks for watching. Please pass it on to your friends and subscribe to my channel.